Greetings from the Hermitage, and welcome to this demonstration of using systems of equations for balancing chemical reaction equations. I assume in this demonstration that you already have some familiarity with solving systems of equations and with balancing chemical reaction equations. For this presentation, we'll be using the reaction of phosphoric acid with calcium hydroxide to produce calcium phosphate and water. I initially write the chemical equation with letters as the coefficients, and I start with, I just typically use A, B, C, and D letters early in the alphabet so I don't have to memorize the entire alphabet. The first thing we do in this technique is to write an atomic species equation for each of the atoms in each of the molecules. I start off with hydrogen, and for those of you who are a little rusty on doing this, this 3 is this subscript 3 on hydrogen here. The letter is always going to be the coefficient. So we have 3 atoms of hydrogen. That's going to be 3 times A. We move on to the calcium hydroxide. There are 2 atoms of hydrogen in that molecule. That 2 times the coefficient. Now we move on over to the right-hand side of the equation. We're looking at hydrogen. There's no hydrogen in calcium phosphate, but there's 2 atoms of hydrogen in each molecule of water. So we take this 2 and multiply it times the coefficient D. And we do that on each element as we move from left to right across the equation. You may want to pause the video at this point if this is a little unfamiliar and see if you can derive the same equations that I did here. Check me out, make sure that I did everything right. Once we get to this point here, this set of equations, is my system of equations that we're going to be using to get the coefficients for that reaction. What I do at this point is look for the simplest equation within that set of equations, the one that has the least number of terms. In this case, we have 2. The equation for phosphorus only has 2 terms, and the equation for calcium only has 2 terms. Makes our life a lot easier. So let's go ahead and write those equations on a separate page. So we have 1A equals 2C. And recall that what we're looking for are the smallest whole numbers that are possible for that chemical reaction. And we want whole numbers, not fractions. So in this equation right here, I'm going to choose 1 as the smallest whole number in our system of real numbers. And I have a choice. I can either let A equal 1 or I can let C equal 1. Let's see what happens if I let A equal 1. So in that case, we would have 1 times 1 equals 2C. Then dividing each side of that equation by 2, right, we would have 1/2 equals C. That's not exactly what we want. Remember, we want whole numbers in our equation, in our reaction equation. So instead of letting A equal 1, let's let C equal 1, and then we'd have 1A equals 2 times 1, in which case we have A equals 2. We'll go ahead and box that in because we're going to bring that forward a little bit later. The same thing now in this equation. We'll let C equal 1. So in that case, we have B equals 3 times 1, and B equals 3. We'll box him in and bring him forward. So as a reminder, at this point, we have C equals 1. We solved for B equals 3 and A equals 2. All that's left for us to do is to take these letters, the value for these letters, and substitute it in for each of these equations that I've written here. I'll take the simplest equation first. So this is going to be 3 times A, and A is 2. So I'll write a 2 there. Add 2 times B, that's going to be 2 times 3 equals 2D. 3 times 2 is 6, plus 2 times 3 is 6, equals 2D. This is 12 equals 2D, and at that point I can divide each side by 2 and get 6 equals D. Now, we don't have to do the other side, but it'll be a really good check on us to make sure that we made all these calculations on the left-hand side correctly. So we'll do the same thing with this equation over here on the right-hand side. We'll substitute the values of these letters in there. So it's going to be 4 the value of A is 2, plus 2 times the value of B is 3, and the value of C is 1, so that's 8 times 1 is 8, plus D. Remember, D is what we're solving for. 2 times 4 is 8, plus 6 equals 8, plus D. This is 14 equals 8 plus D, subtracting 8 from each side. We get 6 equals D, which is the exact same result that we got on the left-hand side of this page. Now all that's left to do is to take all these values that we've calculated and put into the equation, and that's going to look like this. At the top of the page is the original equation with the letter coefficients. These are the values that we calculated for those coefficients, and all we'll do now is take these guys and put them into the original equation, and we get this result. You may want to go through and check everything to make sure that we've done it right. If I haven't done it right, be sure and let me know in the comments. So if you feel pretty confident with this and you want a challenge, you're feeling really froggy, this is a pretty tough problem to balance. Okay, I've given you the answer. Just recommend that you go back and put in the letters instead of the numbers and then work through it. It's difficult, okay, it's a challenge, but I'm confident that you can do it. So with all of that said, there's only one thing left to say, and that is, that's all, folks. Be safe. Con cuidado.